So this is part 2 of Newton's law of cooling. A cook monitors the temperature of a roast that is in an oven set at 180 degrees Celsius, given 180 degrees Celsius. So what is 180 degrees Celsius? That is T sub S, because the oven was set at 180, meaning the temperature will be constant. At 12 noon, the temperature of the roast is 110 degrees Celsius. Do we know how much time has passed since the cook put the roast in the oven to 12 noon? No. So we can let that time equal to X. X is the time that passed by from the time the cook put the roast in the oven to 12 noon. And at 1 p.m., the temperature of the roast is 160. So what will be our T or time? So our time will be X plus 60, because from 12 noon to 1 p.m., the time that passed by is 1 hour. So that is equivalent to 60 minutes. So X plus 60. If the temperature of the roast was initially 20 degrees Celsius, so that is T sub O, that is when the time is 0, what time was the roast put in the oven? What is asked is time the roast was put in the oven. So let's start at 12 noon. T is equivalent to X and the temperature is 110 degrees Celsius. Our formula is T minus T sub S equals T sub O minus T sub S e to the KT. The temperature when the time is X is 110 degrees Celsius minus Ts is 180 equals T sub O is 20, Ts is 180, e to the k, then T is X. 110 minus 180 is negative 70. 20 minus 180 is negative 160. E to the kx. Divide both sides by negative 160. So negative 70 divide negative 160 is 7 over 16. Negative 160 over negative 160 is 1. So e to the kx. At 1 p.m., T is equivalent to X plus 60. So the temperature is 160 degrees Celsius. The formula is T minus Ts, To minus Ts e to the KT. The temperature when the time is X plus 60 is 160. Ts is 180, To is 20, Ts is 180, e to the k, and the time is X plus 60. 160 minus 180 is negative 20. 20 minus 180 is negative 160. K times X is Kx. K times 60 is 60K. Then we divide both sides by negative 160. So negative 20 divide negative 160 is 1 over 8. Negative 160 over negative 160 is 1. So only e to the kx plus 60k. Then using the law of exponents, e to the kx plus 60k is equivalent to e to the kx times e to the 60k. And e to the kx is equivalent to 7 over 16. So 1 over 8 equals 7 over 16 e to the 60k. Then, divide both sides by 1 over 7 over 16. So, 1 over 8 divide 7 over 16. Answer is 2 over 7. 2 over 7. And 7 over 16 divided 7 over 16 is 1. So, only e to the 60k. ln both sides. So, we have 60k ln 2 over 7. Then, divide both sides by 60. Our k is equivalent to 1 over 60 ln 2 over 7. Since we have the value of k now, we will use that to our equation 7 over 16 equals e to the kx so that we can get the value of x. So, 7 over 16 equals e. K is now 1 over 60 ln 27. 1 over 60 ln 2 over 7 times x. ln both sides. So, ln 7 over 16. So, this is now 1 over 60 ln 2 over 7 times x. Then, divide both sides by 1 over 60 ln 2 over 7. Our x is equivalent to ln 7 over 16 all over 1 over 60 ln 2 over 7. So, x is equal to ln 7 over 16 1 over 60 ln 2 over 7 equals, time is 39.59 round off to 40 minutes. So, x is the time that passed by from the time the roast was put in the oven to 12 noon. So, we will subtract it to 12 noon. So, 12 noon minus 40 minutes. Therefore, the roast was put in the oven 11:20 in the morning. So, this is our answer. Last example for Newton's law of cooling. At 6 a.m., the temperature of a corpse is 13 degrees Celsius, and 3 hours later, it falls to 9 degrees Celsius. Given, at 6 a.m., temperature of the corpse is 13 degrees Celsius. Do we know how much time has passed since the person was killed to 6 a.m.? No, right? So, we can let the time equal to x. X is the time from the person was killed to 6 a.m. Then, after 3 hours, so that is 9 a.m. So, our t must be x plus 3. So, the temperature is 9 degrees Celsius. The living body has a temperature of 37 degrees Celsius, that is T sub O. That is when the time is 0. Assuming the temperature of the room is in which the body rests is 5 degrees Celsius, so that is T sub S. Estimate the time of death. Time of death. So, let's start at 6 a.m. T is equal to x, and the temperature is 13 degrees Celsius. Formula is T minus Ts equals T sub O minus Ts e to the kt. What is the temperature when that time is x? 13. Ts is 5. Initial is 37 minus 5 e to the k times x. 13 minus 5 is 8. 37 minus 5 is 32. E to the kx. Then we divide both sides by 32. So 8 divided 32 is 1/4. 32 divided 32 is 1. So e to the kx. At 9 a.m., time is x plus 3. And the temperature is 9 degrees Celsius. The temperature when the time is x plus 3 is 9. Minus Ts 5. TO 37 minus Ts 5. E to the k, then time is x plus 3. 9 minus 5 is 4. 37 minus 5 is 32. E to the k times x is kx plus 3 times k is 3k. Then we divide both sides by 32. So 4 divided 32 is 1 over 8. 32 divided 32 is 1. So we have e to the kx plus 3k. Using the laws of exponents, e to the kx plus 3k is equivalent to e to the kx times e to the 3k. And e to the kx is equivalent to 1/4 times e to the 3k. Then we multiply both sides by 4. So 4 times 1/8 is 1/2. 1/4 times 4 is 1. So e to the 3k. Then ln both sides. So ln 1/2 is equivalent to 3k. Then divide both sides by 3. So we have k equal to 1/3 ln 1/2. Then use this one. Use our k to find the value of x. So e to the kx. So 1/4 k is 1/3 ln 1/2 times x. Ln both sides. So ln 1/4 equals 1/3 ln 1/2 times x. Then divide both sides by 1/3 ln 1/2. Our x is equal to ln 1/4 all over 1/3 ln 1/2. So our x must be ln 1/4 1/3 ln 1/2. 6 hours. So 6 hours has passed before 6 a.m. hits. So 6 minus 6. So from 6 a.m. reverse. So 5, 4, 3, 2, 1, 12 midnight. 1, 2, 3, 4, 5, 6. So the time the person was killed is 12 midnight. So that ends the examples for Newton's law of Coulomb.